In this video, let's revise research for the preliminary exams. So I will be covering the topics of basics of epidemiology, measures of disease occurrence, and about epidemic, endemic, pandemic, and all those important terms. And I will also be discussing few formulas which we can apply to solve few mathematical questions too. So let's get started. First, the basic definition of epidemiology. It is the studying of the distribution and the determinants of a disease in a given population. Okay, simple. Distribution and determinants of disease are the keywords. When you study that in a population, that is called epidemiology. Now, clinical epidemiology is the application of epidemiology into the clinical practice. So, using the studies done by epidemiologists and research people, we apply those studies for the betterment of our patient. Now, that is called clinical epidemiology. Now, there is this method called evidence-based method, evidence-based medicine. Okay, this evidence-based medicine is based on three factors: patient concerns, best research evidence that is available, and then clinical expertise. When we apply all these three together, that is called evidence-based medicine. Now, in one of the evaluations exam, there was a question asking which one of the following is not a factor in evidence-based medicine. And one of the options were social concerns. So in this three, you don't see social concerns, right? So obviously that is the exception. Now, for evidence-based medicine, there are steps that we need to follow, starting from finding a clinical question. So when there is a case presented to us, we must make sure that this case is presented in a form of a clinical question which can be searched for materials, for resources. So starting with ask, that is forming a clinical question which is in searchable format, then acquiring the clinical question, acquiring the resources for it, then appraising the resources. By appraising, I mean promoting the resources and going more deep into it. Finally, applying and then assessing. So again, in the exam, there was a question in which they had given four options and they asked which one of the following option is the last step in evidence-based medicine. So they gave ask, acquire, appraise, and apply. So when only four of these options are there, apply will be the last step. But if they're going to give all these five options, assess is going to be the last step. Now, there is something called as PICO, patient intervention comparison and outcome. We do this to find the question which can be searched, right? So for that, let's take an example. The effect of guava leaves decoction versus placebo on the frequency of stools in patients with acute gastroenteritis. So in this, who is the patient here? Patients are the ones with the acute gastroenteritis. Okay, patients are the ones with the acute gastroenteritis. Now the intervention here is the guava leaves decoction. Okay, that is the one we are giving as an intervention to these patients. Now, what are we comparing this intervention with? We are comparing this intervention with placebo, which is basically nothing. Okay, we are comparing this with placebo, and the intervention is your guava leaves decoction. Now, what is the outcome? What are we trying to bring out of this? We are trying to analyze the frequency of stools in these patients. So the outcome here is the frequency of stools. This is how you determine patient intervention comparison and outcome. So once we do this, evidence-based medicine is going to be really easy. Now, what are all the source of evidences that we can refer to? There are primary sources and secondary sources. Primary sources will take a lot of time to verify and analyze because they are not yet final. But secondary sources are the ones which are already reviewed. They are already reviewed by researchers and they're uploaded in professional sites so that we can take a look at it. Now, so the primary resources are Medline, PubMed, Medscape, and Elsevier. Whereas the secondary sources are your Cochrane and then clinical practice guide and all the other possible best evidences. Okay, so know the difference between primary sources and secondary sources. Secondary sources are already reviewed, whereas primary sources are not yet reviewed. Okay, now here are some basic definitions we must know. Number of cases, ratio, proportion, rate. Number of cases is obviously the number of cases given in a population. For example, let's say 36 people have Zika virus or something like that. So the number of cases is 36, simple. Ratio is something in which the numerator is not part of the denominator. For example, let's say there are 10 doctors out of 1,000 people in India. Okay, 10 doctors and out of 10,000 people. Now, these 10 doctors are not necessarily part of the denominator. They are separate group of 10 people apart from the 1,000 we have. Okay, so ratio values are like this 10 is to 1,000. Whereas proportion will always have the numerator in its denominator. Okay, let's say total number of cases, and new number of cases divided by total population. So obviously these cases are also part of the population. So the numerator is also part of the denominator. That is the difference between ratio and proportion. Now there was one question based on this which I'll be discussing in the end when we do the final analysis. Now rate. Anything with respect to time is rate. Okay, simple as that. Now, to measure the occurrence of diseases, there are specific formulas and terms. First, let's talk about risk. Risk is always a probability of a negative event happening. So here, in this case, it is the probability that an event will occur. In our case, let's say it is the probability that a disease will occur. Okay. Now there's another thing called as cumulative incidence, which is also known as incidence proportion. Now cumulative incidence is the total number of new cases during a period divided by the population at the beginning of the period. Now the key points to note here is divided by the population at the beginning of the period. For example, in the question, if they are going to say the disease began in 2004 and extended till 2007, in this case, for the denominator, we have to use the population of the group or of the city or of the country during the beginning of the period of the disease. Okay, only during 2004 we have to measure the number of people and put it in the denominator. So once again, new cases during the period. So from 2004 to 2007, how much ever cases we had, divided by the population at the beginning of the period is cumulative incidence. Now, what is attack rate? Attack rate is nothing but your cumulative incidence during an outbreak. So let's see what is outbreak in the upcoming slides, but just remember cumulative incidence during an outbreak is called attack rate. Okay, and this attack rate is expressed for the entire period of your epidemic. Now an outbreak becomes an epidemic and an epidemic becomes a pandemic. So understand that attack rate is the one that is expressed for the entire period of your epidemic. Now, what is incidence rate? We saw cumulative incidence rate. What's incidence rate? Incidence rate is the number of new cases divided by the total number of person during the time of observation. So let's say you're observing a population from 2003 to 2006. Okay, so the total number of population during this time comes under the denominator here. It's not the same of it's not the same as cumulative incidence. Okay, now what about prevalence? Prevalence is the new number of cases at a specific time divided by the population of interest at that time only. So this is like more specific. New number of cases at a specific time divided by the population of interest at that specific time only. Okay, that is prevalence. Now there is another interesting concept called R. Okay, don't ask me the full form of it because I don't know. R decides how contagious an infectious disease is. For example, let's say R is 18. That means an affected person can affect 18 more people, can cause the same disease to appear in 18 more human beings. That is the meaning of R. Okay, now for the R to be ideal, there are three criteria. The criteria number one is no one in the population has been vaccinated against the disease that person has. Criteria two is no one has had the disease before. Criteria 3 is no way to control the spread of the disease. There is no new way found that can be used to control the disease. So these are the criteria when your R is applicable. Okay, R is simply the number 18, let's say example 18. So for example, if a person A is infected with a disease and if he has a R value of 18, it means he can infect 18 more people with the same disease. Now, what if R is less than 1? That means one person can infect less than one, right? So the graph is declining. Whereas what if R is equal to 1? So that means one person can affect only one. It's not exponential growth. One can affect only one. Once, okay, not more than once. Only one once. So the graph is going to be a plateau. What if R is greater than 1? That means one person can affect more than one people. So that means the graph is going to go up, It's going to incline. Okay. Now, what are the factors that affect R? It is the period of infection, the contact rate, like how much the disease transmits, and the mode of transmission. Okay, these are all the factors that decide the value of R. Now, another set of terms that we must know. Epidemic. Epidemic is the unusual occurrence of a disease. So I've just mentioned the key points here. Unusual occurrence of a disease in a population. Outbreak is it's a smaller level of epidemic. So as I said before, outbreak leads to epidemic and then epidemic leads to pandemic. Now what about endemic? Endemic is the constant presence of a disease in a geographic population. Okay, for example, let's say hepatitis A or cholera. We had this question in the exam in which I think this was in microbiology exam, in which the cases of malaria are more in Palawan in the Philippines. So that is endemic. That means Palawan part of Philippines is more prone to malaria. So that is endemic. It is to a geographic population, isolated to a geographic population. Now, what is sporadic? Sporadic is something scattered, irregular, and infrequent. And examples for that is tetanus and herpes zoster. What about pandemic? As I said before, pandemic is the exaggerated version of epidemic in which this epidemic grows beyond borders. Okay, and the example for that is HIV, AIDS, influenza, and obviously the COVID-19 virus now. Now, what is primary case and what is index case? Primary case is the first case of a communicable disease in the community. Index case is the first case you saw in the community as an investigator. It is not necessarily the primary case or the first case. It is the first case you saw. Okay, that is the index case and used it for your investigation. Okay, we're almost there. Few more terms. What is suspect? Suspect is the patient with specific signs and symptoms related to the disease. Now, when can you call a suspect as confirmed? Confirmed is when the laboratory results confirm the specific signs and symptoms. Now, when can you call a person probable to have the disease? It is when the disease has a unique result in a particular period of time. Okay. Now, there is this criteria to confirm epidemic. Okay. What is that criteria? There should be a 25% increase in the cases of a specific disease compared to the average of the past 4 years appearance of those diseases. Okay, let's say 2023 now. So 2022, 21, 20 and 19, there has been this disease. Okay, but not a lot. So you take the average of that, and if the 2023 count of the disease is more than 25% of the average you took, that means you can confirm that it is an epidemic. Okay, and remember, all these 4 years should be non-epidemic years. Fine? Now, there is something called as data analysis and writing the report, okay, after you do the epidemic investigation. Now, data analysis deals with three factors: time, place, and person. There can be MCQs asked based on this. Now, writing the report has this order: background, historical data, methods of investigation, analysis of data, controlled measures. Now, for this, you can remember something like BMAC. So it's like beam, BHM beam, and then BMAC. So something like that you can remember for the sake of MCQs. Okay, now finally, this slide is pretty much self-explanatory, but one thing I would like to explain here is isolate, the difference between isolate and quarantine. Isolate is when a patient isolates himself when he or she has tested positive for the disease, okay, regardless of the person having symptoms or not having the symptoms. But quarantine is when a person has come in with contact or as a precautious measure. Okay, and the person has not tested positive. That is quarantine. Okay, rest of the things you can just take a look at it and revise it by yourself. Now, finally, this is the analysis out of the evaluation exam. So there was a question based on mortality rate. That was very self-explanatory question. And as I said, ratio and proportions. It's very important to understand. All proportions are ratio, but not all ratios are proportions. Okay, remember, proportions and ratio, what was the difference? Ratio was the one in which the numerator was not there in the denominator. Okay, but proportion was the one in which the numerator was present in the denominator too. So that's why all proportions are ratio, but not all ratio are proportions. Now, based on PICO, there were two questions which you had to, something related to the lipid ratio. Now you know the definition of endemic and pandemic. Incubation period definition is already there. Now, what in malaria is the vector, the mosquito, it is the vector, right? Now, chronic diseases, prevalence or incidence. Based on the definition of prevalence or incidence, there was one question. Now, just disregard this. Now, questions based on evidence-based study. What is the exception? Remember, patient concern, best research evidence, and clinical expertise. Social concern is not a part of it. So remember that. What is the last step in evidence-based medicine? So they gave these four options and they asked which one is the last one. So application is the last one. If there was assessment, assessment would be the last one. Now, again, many questions were based on studies about which I'll be telling you shortly, prevalence, cumulative incidence, and then your foodborne diseases. There was some question related to foodborne diseases, but that was self-explanatory. Now, for people who face difficulties in doing the mathematical equations at the last moment, see, for these exams, they don't really give complex numbers. The numbers might look complex. For example, let's say 47 and then let's say 94,000. Okay, let's say 47 people had the disease, new cases, and 94,000 was the population of the city or the group. Now you might think, oh, this is a very big number. I'm not able to do the math. See, it's very simple. 47 divided by 94,000. They are giving really easy ones. 47 into 2 is actually 94. Or you can do 47 plus 47, which is 94. Okay, so that's just 2. So 1 divided by 2 is zero point 0.5, right? And you have three zeros down here. So into 10 to the power minus 3 or multiply or divide it by the three zeros that is present here. You can do any one of these. Okay, it's that simple. See, once you see that this is 5 and if you see any option with 5, you go ahead and tick that option as the right one. Because the options they are giving are very different from each other. They are not the same. So once you get it as 1 by 2, 1 by 2 is zero point 0.5. So you see any option with 0.5, 5,550, anything related to that, you can go ahead and give that as your answer. So that was all about research analysis and revision. I hope it really helped. Thank you.